12.4 continues with probability. Now we're talking about the probability of disjoint and overlapping events. So events that have an impact on each other or don't, or events that can, like two events that can both occur at the same time, or separate events is kind of the idea behind disjoint and overlapping. So these are just a little bit of visual representations of what it can look like if your events can overlap. So this is compound events, okay? It says when you consider all the outcomes of two events, A and B, that there can be a union or an intersection of them. So if you have probability that A is occurring and probability that B is occurring, and there is an option in which they can both occur. So a lot of these come from, let's go simple, like a dice, okay? So if I say that probability that the first event is occurring is the probability that an odd number is rolled, okay? And then I say, so let's say A is that an odd number is rolled. A is that an odd number is rolled. And B is that something that is less than 4 is rolled. Is it possible for there to be an overlap there? So is there a number that when I roll the die, there's a number that is both odd and less than 4? Does that exist? Yes. Okay, so that's kind of the idea behind this. When you have an overlap or an intersection of them, the union of it is all the options. So it's all the options of A and all the options of B. So if I were to say what are the possibilities for A or B, let's say, then it would be odd, so it would be 1, 3, 5, and it would be everything less than 4, which would be 3, 2, and 1. You with me so far? That's considered to be a union. So all of the options of A and all the options of B. The intersection of them, which is drawn by this little Venn diagram here, is where they overlap. So if I asked for the intersection of A and B, what would you give me? What is both odd and less than 4? What? 3 and 1. Does that make sense? Yes? So in this little A, in this case, would be 1, 3, 5, 7. And on the right, it would be 1, 3, or 1, 2, 3. And then in here are going to be the overlap. So this is going to be 1 and 3. Out here would be 5 and 7. Out here would be 2. Does that make sense? So we're reading a Venn diagram. Union is all of it. Intersection would be where they overlap. And then let's say the intersection of A and B is empty. So let's say that A is the possibility of rolling an odd and B is the possibility of rolling an even. Is it possible to do both A and B? Is there a number that is both even and odd? No. You with me? Yeah? That would be something like the last one. Okay? So this is just a little bit of vocab for you. So union is all the outcomes for either of the events. So if I asked you for the union of A and B, you would list all of A and all of B. The intersection is only the ones that exist in both. And overlapping events are events that have at least one element in that overlapping or intersection. Disjoint does not. So the first example where I give you A is odd and B is less than 4 would be an example of an overlapping event. And if I said A is odd and B is even, this would be an example of a disjoint or mutually exclusive event. It cannot be both. Yes?
So I'm so confused on the difference between union and intersection.
Union is literally everything. So if I said, oh gosh, I almost said something that would be really, really awkward. Let's say I say, think of something that overlaps. I almost said boy and girl, which then the intersection could be a whole different conversation that we shouldn't have in class. So let's say, my goodness. Okay, so let's say we're polling people, right? And we're talking about their background, and I pick Irish Italian just because that's what I am. Okay. And I'm saying, okay, how many Irish people are there? Okay, so there's Irish. How many Italian people are there? And then there's some people that are both Irish and Italian. Okay, they would be in that overlap. Does that make sense? So if I asked you for what's the sample size for Irish and Italian, the union of them, it would be all of it. It would be everybody that's in that box. Okay? If I asked you for the population of the intersection, it would be only the ones in the middle that overlap that are both Italian and Irish. Does that make sense? Okay. So the probability of compound events is found two different ways. If the events can overlap, okay? So an example, if you could be both Irish and Italian, okay? Then you're going to find it the first way. You're going to find the probability of being, let's just say we go with this example, the probability of being Italian, the probability of being Irish, and you subtract from it the probability of being both Italian and Irish. So if it was the first example with the rolling of the die and it was odd or less than 4, then I would find the probability that it's odd. So if I roll a dice, what's the probability I'm going to roll an odd number? How many odd numbers are on? 3 to 6, right? Or 1/2, right? You with me? What's the probability of rolling something? Actually, I'm going to leave it as 3 over 6 because it'll be easier in the long run. 3 over 6. What's the probability of rolling something that is less, what was the number I gave you? 4? Less than 4. Also 3 over 6. What's the probability of rolling something that is odd and less than 4? 2 out of 6. So this is how I would find that probability. I would find the probability of the first one, the probability of the second one, and subtract from that the probability of the overlap. Does that make sense? Because you can't count it twice. Does that make sense? Yes? So this would be 3 plus 3, which is 6, minus 2, which is 4, 6, or 2/3, if we were to use that example. Which should make sense if you're looking for the probability of the overlap. Okay. So then the second part is if they're disjoint. So this would be an even or an odd. So what's the probability of rolling an even? And what's the probability of rolling an odd? And for these, you don't subtract anything. You would just add them. So the evens are going to be the 3 out of 6s. The odds are going to be the 3 out of 6s. This is going to be 6 out of 6, which is 1 to 1, which should make sense. If I'm rolling a die, I'm either going to roll an even or an odd, right? Every time I would get that option. Yep.
Why do you subtract the top one but not the bottom?
Because you can't account for it here and here if it overlaps. It's almost like you're accounting for it twice. So you've got to remove the part that happens for both. Okay? That's if there. So disjoint, you just add. But if there's an overlap, you've got to subtract from it the overlap. Questions so far? All right. So let's see if you can work these out, dealing with what we just said. A 6-sided die is rolled, find the probability of each. So think about it first. Ask yourself, are these disjoint or are they overlapping? And then from there, you should be able to approach it the way that is appropriate. Okay, a 6-sided die is rolled. Find each probability. So the first one is the probability that the number rolled is less than 3 or greater than 5. So you want it to be in between 3, or sorry, less than 3. Less than 3, greater than 5. Is this an overlapping or disjoint? Disjoint. There's no number that can be less than 3 and greater than 5. Make sense? So I want to find the probability that it's less than 3. How do I do that? Or what would that be? 2 out of 6. 2 out of 6. And the probability that it's greater than 5 would be 1 out of 6, which is 3 out of 6, or 1/2. Okay? Or 0.5 or 50%, depending on what it's looking for. Good so far? All right, the probability of rolling a number greater than 4 or even. So greater than 4 or even. Disjoint or overlapping? Overlapping. So greater than 4 is what out of what? 2 out of 6. Even is 3 to 6. Overlapping would be? Good. Oh, sorry, minus 1 out of 6. So 5 minus 1 is 4, 6, or 2/3. Easy stuff, right? All right, so it's interesting, but your knowledge on a deck of cards is going to reflect on your grade in this class, okay? So here's what a deck of cards looks like. If you don't play with a deck of cards, or you don't know much about a deck of cards, you want to make sure that you study this slide, okay? In a deck of 52 cards, so we are not considering jokers to be in a standard deck of cards, there are 4 suits. There are clubs, spades, hearts, and diamonds. The face cards are the ones that literally have a face on them. So these are the jacks, the queens, and the kings. There are 13 cards in each suit. So there are 13 clubs, 13 spades, 13 hearts, and 13 diamonds, which means there are 26 red and 26 black. And they are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. You literally need to know the deck of cards in order to answer some of these probability questions. It should say, a number less than 5, ace is low or ace is high. So ace is low means it counts it as a 1. Ace is high means it counts it as the highest value, almost like a 13. Okay, a card is randomly selected from a standard deck of 52 cards. Find the probability of the given event. Again, you want to approach it, is it disjoint or is it overlapping? And then go from there. So A, selecting a 5 or a face card. Can it be both a 5 and a face card? No, so these are disjoint. How many 5s are there? There are 4 out of 52. How many face cards are there? 12. There are 4 jacks, 4 queens, and 4 kings. Everybody understand that? So this would be 12 out of 52. 16 out of 52, which reduces. All right, this would be 4. Actually, it goes with it. 4 and 13. B, selecting a face card or a diamond. So can it be both a face card and a diamond? Yes. Okay. So probability of it being a face card. There are 12 face cards. Probability of it being a diamond. 13. There are 13 of each kind. 13. And the overlap. So how many are both face cards and diamonds? 3, right? There's 1 jack, 1 queen, and 1 king. So this is 25 minus 3, 22 over 52, or 11 over 26. Questions so far? Yep. Correct. It literally has to have a face on it, so it's a person. So it's the jack, the king, and the queen. All right, C, selecting an ace or a 9. Disjoint or overlapping? Disjoint. Can be both an ace and a 9. How many aces are there? 4 out of 52. 9. 4 out of 52. And a 10 or a diamond. Disjoint or overlapping? Overlapping. How many 10s are there? 4. How many diamonds are there? 13. And how many are diamonds and a 10? 1. So this is 17 minus 1 is 16 over 52. Your homework for this weekend is going to be go home and familiarize yourself with a deck of cards. Okay? Questions so far? Okay. I'm going to skip this one. I really hate the wording on this question, and it's not like anything in your homework, so skip it. Okay. Complement of an event. So the last thing we'll talk about in this section is a complement. We've talked about complements in a lot of different ways, right? We talked about the complements of an angle, that kind of stuff. This is different, sort of. So this consists of all the outcomes that are not in an event. So if I tell you that the probability of getting something is 3/4 or 3 out of 4, okay? What's the probability of not getting it? 1 out of 4. That's the same idea as the complement, except that usually complement is given in decimal format. So if I tell you that the probability is 0.75 of getting something, what's the complement? 0.25, okay? So you take 1 and you subtract the probability from it, okay? Whether you do, if it gives it to you in fraction format, you can give it back in fraction format. A lot of times you'll see this in decimal format, which you'll see in a second, okay? The notation for a complement, A, so if it's event A, then you get A with a little segment over it, and that's read as A bar, okay? So that's, if I say B bar, I mean the complement of B. That's what that means, okay? So this says, when a 2, 6, 6-sided dice are rolled, find the probability of each event. Okay, so number 1 says the sum is not 6. So they already gave you the chart. Like if the first die is rolled a 1, 2, 3, 4, 5, and the left side is, this is called a Punnett square, right? So like if I add those two together, 1 and 1 is 2, 2 and 2 is 4, that's where these boxes came from, but they already did that for you. So if it's not a 6, then I'm looking for all the boxes over here that don't have a 6 in them. Are there more of those, or are there more of ones that have a 6? More that don't. So this is a scenario in which the complement's going to help you out. Because you could sit here and literally count all the boxes that don't have a 6, or what? Count the ones that do have the 6 and find the complement. Does that make sense? Okay, which is obviously a lot easier. So there's 1, 2, 3, 4, 5 that have 6s. Everybody sees that? How many are there total? 36. So if 5 out of 36 is what I don't want, then I would do 1 minus 5 out of 36, or 36 over 36 minus 5 out of 36. And I get 31 out of 36. Questions so far? So that's a way in which obviously the complement might make it faster. Chris?
If there was a different number, like 17, would you change the 1 to 17 over 17?
Yes. So you want the denominator to be the same. So if it's 1, you change it so that it's the denominator over the denominator. Yeah. Okay, the sum is less than or equal to 9. So again, looking at this, okay, if it's less than or equal to 9, are there more that are less than or equal to 9, or more that are greater than? There's more greater than. So this is another incident where it's going to be easier. I would either have to count all these 9s over all those boxes, okay, or I could figure out what would be to the greater than 9 part of it, which is how many? 6 out of the 36. And I could subtract that from 1. So 1 minus 6 out of 36. And you can reduce that even if you wanted to, make it a little bit smaller. So 1 out of 1 minus 1/6 would be 6/6 minus 1/6, which is 5/6. Yep. Yeah, and most likely you're not going to get this exact example, right? So it'll be some sort of way. You'll see in the homework too where it could just say, you know, A is point, like we did before. Let's say A is 0.3, and then it's going to ask you for A bar. So that's how else you could see the complement, which would be what? 0.7. Okay, you'll see it stuff like that. And then you could say, I mean, there's a couple of different ways you could see this. You could see B is, let's say it's 0.5. What is B bar? 0.5. And then you'll see stuff like, what is A, B? What's the probability of A and B? Or you'll see what's the probability of A. So you got to start to understand this notation. Probability of A plus the probability of B. So you do 0.3 plus 0.5, right, which would be 0.8. Or you could say probability of A plus the probability of B minus the probability of, they would give you this, but A, B. So this one you can't do just with the information I gave you. But what does that mean? What is probability of A plus probability of B minus the probability of A dash B? What does that mean? It means that there's some sort of an overlap, right? Does that make sense? So you would have to be given probability of A and B in order to find that. But you'll see when you get to the homework that sometimes you're given kinds of different information like that.
I'm confused. Like, are you supposed to find what it tells you, or the opposite?
So in the